Hi, good afternoon, one and all. This is Srigada Arvind, Software Quality Engineer here at Menlopark Technologies. Moving ahead to our second session of the day, we now have with us Mr. Thomas, Director of Sales and Business Development at Zena Networks. Mr. Thomas will be delivering technical presentation on automotive switch testing from design to production. We'll learn about production line testing, regression testing, during the development process and validation of switches using component integration. Menlopark Technologies is a leading provider of design, development and testing tools to device software manufacturers in automotive, automation and aerospace industries across the globe. Our engineers can advise you on the best product set to suit your technical and business needs. And we offer product configuration and bundling of hardware and software solutions for hassle-free product development. Mr. Thomas is responsible for the global business development of Zena's Automotive Ethernet and time-sensitive networking products. He also heads Zena's sales activities across Europe, Middle East, and African territories.
Welcome to the presentation of Automotive Ethernet switch testing from Zena Networks. My name is Thomas Schulze. I'm working as a director of automotive business development for Zena Networks almost a year now. Before I joined Zena, I was in several test and measurement companies, and mainly for the last 5 years, I was responsible to build up automotive Ethernet and automotive testing in general for new technologies, vehicle-to-X communication, for example, but mainly focus on automotive Ethernet testing. So therefore, I have a strong background in automotive Ethernet testing and want to give you today a quick overview on how and why to test automotive Ethernet switches. So let's start with the presentation. Here we go. So in general, as I said, the focus is Ethernet switch testing from research and development to production. So the contents of this presentation is mainly for sure the switch testing, but I give you also a quick introduction of Zena Networks, then the general challenges, how to choose the right switch vendor and how to choose a switch in general, how to validate the component integration of switches, so a switchboard into your ECU or even a complete switch device in your environment. Regression testing during the development process, and also a quick overview of production line testing. If you are, for example, a tier 1 supplier and you want to do quality assurance of Ethernet as well in end-of-line testing. Quick conclusion at the end. So, who is Zena Networks? Zena Networks is founded in 2007 in Denmark, Copenhagen. Today we have our headquarters in Lyngby, which is northwest from Copenhagen, but definitely in the suburbs of Copenhagen. So we still say we are from Copenhagen. And Zena Networks is a manufacturer of Ethernet test and measurement equipment. And we're also providing services in this area. Our research and development is mainly in Lyngby, but we have also offshore development in the Netherlands, and also we have some engineers in China working on our products. We have several sales and technical centers around the world in Europe and the US and India and also in China, but mainly our sales force and technical support force is provided by our great channel partner network. So we have multiple channel partners in different regions, and also we have specialized automotive channel partners with a strong automotive test background or even automotive engineering background. So what are the Zena products as an overview? As I said, we are focusing on Ethernet testing, but we do have for Ethernet testing multiple product lines, and not all are today used in the automotive industry, but to not hide the products for you, I want to explain all products line quickly. So first of all, we have Valkyrie. Valkyrie is our stateless layer 2, 3 Ethernet traffic generator and analyzer. And this is the main platform which is used today in the automotive industry for Ethernet testing. As the name already said, stateless Ethernet traffic generation and analysis. We are generating specific traffic going through a device under test and analyzing the traffic on the other side on all different kind of metrics like the line speed, delay, jitter, packet loss, packets out of order. So every kind of analysis you can imagine, which is important for Ethernet. And we're going up to speeds of 400 gigabit, so definitely enough today for the automotive industry. Second product line is our Vulkan product line. Similar to Valkyrie, it's a traffic generator and analyzer, but not anymore in the lower level layers, layer 2, 3. Vulkan is designed and produced for testing higher layers, layer 4 up to layer 7, so application simulation, for example. And it has a stateful traffic generation, which means you can have a real TCP connections, for example, or you can even do secured connections like a TLS traffic generation. It's mainly designed to test routers or firewalls, for example. Chimera is our network emulation product line, and a network emulator is mainly a device where you can emulate the real network behaviors in your lab. So that means if you have a car architecture, a car network architecture, you have multiple switches, multiple ECUs within the car. That means if you are sending traffic from A to B, it has a specific delay. Probably you will have a packet loss. Or also what can happen is some packets out of order, for example. And Chimera is able to emulate these in your lab. So we can add a delay to traffic. We can limit the bandwidth, for example, or even we can throw away all packets that we have to simulate a redundancy failure, for example. Next product line is Sapphire. Sapphire is similar to a firewall tester, but mainly designed for enterprise customers, so very easy to use interface. We do have predefined test suites on Sapphire, so that you don't have to let's say configure your own traffic to be sent over the firewall. You can also use, for example, a firewall lock to create a traffic profile and replay this with Sapphire. Now, Sapphire could be also an option for the automotive world if you have firewalls, for example, included in the infotainment system or in a smart antenna system, for example. Then we have Vantage. Vantage is based on Valkyrie. So very similar on the hardware, but complete different on the software side. Where at Valkyrie, usually test suites or manual test case creation. With Vantage, you have a fully automated platform, which uses just a web browser interface. Even that is not used to configure. It's just to check where the different test stages are, but you will see this also later in the presentation. So, what are the challenges to choose the right switch vendor, or even to choose the right switch for your need? I mean, before we see the challenges, I wanted to show this example architecture that we all are on the same level when we are talking about switch testing and which different ECUs are containing switches. So you see here a pretty modern architecture of a car network, which is not out of my mind. So I made this drawing based on an existing car architecture, which I found. So you can see that we are here working already with a complete Ethernet backbone based on a 10 gigabit interface or 10 gigabit bandwidth in general. So it's in green here. So you can see all 3 domain controller units are connected in this Ethernet backbone. We have additional redundancy in there for a gigabit link between 2 domain controllers, even if we have already redundancy in the Ethernet backbone ring. We have different gateways in this architecture, and for sure multiple ECUs. Every device which is marked with a star contains an Ethernet switch. So these are usually our targets to be tested with CNA Networks test tool. But also an ECU with an Ethernet interface can be tested. So we can do a loopback test, for example, against the ECU, or even can do some bit error rate testing or pseudo bit rate error test, PRBS, to test the PHY and functionality of a single Ethernet port. So if you want to choose a switch or a switch vendor, we have to think about multiple different things which the switch has to be providing or has to be provided. So first of all, the design, right? So what do you need in your environment? Do you need just a chipset and you're designing your own switched environment? Or do you need a switch board, which you just put into your ECU? Or do you need a full switch device, which operates completely independent and is to be used as it is in your network, or is used to be put into an ECU box as an independent switch? Every switch has a specific metrics like what is the speed, what is the PHY, so it can be 100 megabit PHY, gigabit PHY, dual speed PHY. Will it be just base T, so the classical Ethernet with RJ45 like we see in the picture? Will it be automotive Ethernet like base T1? And how many ports we do have from this different speeds, right? We can have different speeds on a switch device, for example, 1 gigabit and 10 gigabit. So that is possible as well. Then the next question is, which protocols should the switch support, right? Is it just classical IEEE 802. Is it with the VLANs, which is usually also standard in every switch, or even will it support time-sensitive networking, TSN, the successor of audio-video bridging, you probably know, with multiple functionalities like timing on GPDP. We do have shaping, traffic shaping. We do have also redundancy options in TSN, which can be used in the automotive industry. And then, for sure, the performance and interoperability. We need a non-blocking architecture. That's a term you probably know from the Open Alliance TC8 or TC11. So we want to make sure if all ports are operating at line rate, so maximum performance. You want to make sure that you don't lose any packet, right? So that's a non-blocking architecture. You will have an average delay requirement from your application, average jitter or maximum jitter requirement. You want to know the startup time of the switch, how quick is the switch operational when you put the power on. And also we have traditional test specifications to be checked. RFC 2889, which is a switch benchmarking test specification, or the RFC 2544, which is a device and network benchmarking specification. Often, let's say, overseen are security and robustness tests, or robustness and security requirements. So we have VLAN separation, for example. You have multiple virtual LANs in your architecture, like infotainment is a virtual LAN. You have ADAS as a virtual LAN, and you want to make sure that no traffic can go from one virtual LAN into the other virtual LAN, right? So you need to test this as well. What happens if you have a broadcast storm? Is your switch robust against it? And how are the redundancy functionalities? Is that working fine? So an example validation process So again, that's something which is let's say recommendation, but it's definitely not something you have to follow. But in general, we will always start with a vendor selection or a specific switch type selection from a vendor. And usually you're just doing a benchmark test, right? You want to quickly find out how perform or how the performance of the switch, how is the function of the switch, and you want to compare this against each other as a real selection. And that's traditional RFC 2544 or the RFC 2889. In the next step, you purchase the switch or a switch component, and then you're doing the device integration into your product. So you will do a spec validation, let's call it like this, with your own test specs, with tests based on public test specs, or not public, for Open Alliance member, not public test specs from the technical committees like OpenTC8 or OpenTC11. Still, you would use the RFC, which we already have seen in the vendor selection, to benchmark also the integration into your device. And then for sure, the functional test based on the dependencies between the switch and the other functions within the ECU. We have regression testing as the next step, which is mainly an engineering quality assurance based on a fixed test plan, which you have designed during the device integration. Regression testing is usually fully automated. And with this fixed and automated, you have a repeatable and comparable test result. So you can go step by step through your design and development, and you can always validate on the same level. In the next stage, you're going into the system integration, with hardware in the loop testing, adding a lot of more functionality to test the interoperability, the robustness of the system, and also the overall functional integration into the system. And then, for sure, you're going into the production line testing, end-of-line testing to ensure production quality. This is usually a high-quantity test, so multiple ECUs in a very short duration with a reduced but focused test plan, and for sure fully automated to be quick in the execution. So moving forward to component validation or component integration validation of switches. Therefore, first, we need to have a deeper look into such a device. So we're taking a domain controller unit out of our architecture, and we can see that the DCU has multiple function areas, right? So we have two switches involved, and 10 gigabit switch, and then the Automotive Ethernet switch. We have a CAN-FD module, we have a diagnostic module, we have a shared memory, and we have the domain application. So we probably have a gateway application as well, and then the core microcontroller or FPGA, which is then doing the processing of the data. Important is that within the integration validation, what we want to make sure, or what we want to prove, is still the Ethernet communication, right? I often hear that if I have tested the Ethernet switch already in the initial step, why should I test the switch again when I integrate the switch into my ECU or DCU? It is important because as you have dependencies within such a design, you probably have less performance or less memory if you are changing specific configuration on the domain application. Yeah, so you have to revalidate if the communication through the Ethernet switches works always as expected or as in your specs described. So it is very important also to do a full test of all Ethernet ports, and also and fully meshed environment, because when you put this DCU later on in a network, this part of the whole solution, right? And if you have a specific problem on one switch, it will influence probably the whole network communication. So what you're doing is for sure the functional test, the performance test, the robustness test, and again with dependencies to the other and further applications you are running in your DCU. If we look into the engineering process, usually this is done in A sample to B sample, so that's done with partial functional hardware and software. So we will not have all test results probably as checked, but in the different stages, we will add more and more OK tests here. Following with a quick video on how an RFC test, for example, works. So let's start with that. An RFC 2544 test suite is always included in your Valkyrie test system. And you can also try this on your own. Just go on our webpage and try Valkyrie. And then you can download the software and connect directly to our lab in Copenhagen. You can do the same, what we can see here. So what we have done is connecting to a chassis, then selecting a specific test module, in this case a 6-port 1 gigabit test module. We are choosing 2 ports here, setting up the test topology, which is fully meshed, and bidirectional test direction, so we are sending and receiving in the full line rate. We are setting up a specific frame size, in this case 512 bytes, and then we are going into test types configuration, because we have multiple tests running in an RFC test, and we can pre-select which test we want to do. In this case, we are just doing a throughput test and then latency and jitter test. We are reducing the duration a bit for the demo, that it not runs 100 hours. You can also do a specific protocol selection. So Ethernet is standard. You can also add VLANs. You can add IPv4 addresses or even IPv6 addresses. With this, the main configuration is done. So we can go further and start the test. You are able to save the test configuration, and then the test will configure, or the test suite will configure the ports, will configure the streams, and then automatically start the test, and we will see results popping up here on the bottom of the screen. So latency and jitter test is just performing, and if it is done, you will see the test system will automatically generate a test report, and it will open up in a PDF file. So now the traffic is almost done. It's stopping, and now it goes as described into a PDF report. In this case, it's a very simple report, right? Again, you can try it by yourself using our lab in Denmark. So regression testing. What is regression testing? Regression testing is done during the main development process. So you have the basic integration of your hardware and software done with the initial step of switch integration. Now you're going into the development mode, and where you change often software, where you change the firmware. We're not changing anymore the hardware, right? And what you want to double check here is continuously the performance metrics and other metrics like delay of the switch. If something changes and something goes wrong, if you are doing specific changes on the system. Regression testing is based on predefined test scripts because you want to do a repeatable test and you want to test the same at every time. Also important that you keep the testing simple, so that the test result is presented like an okay or not okay result, and you only have to go deeper into test results if you have a not okay. That will for sure keep the whole process pretty simple. The setup is also pretty simple. So you have a specific SINA networks test device for Ethernet. You have other third-party test tools also to test the CAN/LIN or other technologies on your ECU. You're doing REST bus simulation for functional testing of the application, and everything combined for sure to get a complete view of the functional quality or the validation of the system. Everything is probably automated through a third-party test management quality system like LabVIEW from NI, or you're using our own test automation tool here also to automate then the third-party test tools. And usually this is done again from sample C to sample D, means from partial to full functional hardware software up to the production ready sample D. We're also supporting different development methodologies like waterfall or agile, so it can be used in all these kind of processes. Test automation is important for regression testing. So what we have done, all our test solutions are coming with a REST server implemented in our solution, so that you can use every kind of REST client. So you can use Python, but even you can do a simple command line bash tool to do the automation. So production line testing, as I said, that's mainly for tier 1 or tier 2 suppliers or chipset manufacturers, because I don't see Ethernet testing performed in end of line of a car, so we will not put an Ethernet test tool to a whole car. That's more to test end of line, the ECUs or specific end devices. So as I mentioned before, end of line testing will be a reduced test focus on very specific metrics like PHY speed, so we will double check the auto negotiation part, or if all PHYs are configured to the correct fixed speed. You're testing the signal quality, you're doing a quick check of the non-blocking architecture, a couple of seconds. You probably do a bit error rate test or pseudo-random bit test. You do the VLAN configuration check, and probably some more custom metrics to be checked. Important is that this is a very fast test, reliable and reproducible, like the regression testing, to have a continuous quality model. And also for sure important is that you can have a high device under test quantity in a very short period. That means multiple devices under test or multiple ECUs to be tested at the same time. The test setup is also pretty simple. So you have again a specific test system like the Vantage Bay, which is connected to again a third-party test management and automation tool, or to our own Vantage Manager, which you will see shortly in the video presentation. And then this test tool is connected, or the test solution system is connected to the test stand, where you can put in multiple ECUs or multiple end devices to be tested in parallel. And again, this is engineering cycle full production, and even the ECUs can be changed automatically through a robot, for example. All of this is designed to run long time. So we have installation running 40-day plus without any reboot of the system. So if it is fully automated, you probably have to do some support on this every month or every couple of 40 days, right? The test stand in general can be everything you can imagine: temperature chamber, traditional test stand, an EMC test stand, where you probably have to change between copper to fiber and then again to copper to have a full electromagnetic compatibility. Again, now we are watching also a quick video from one of our clients, where you can see such a production line test system in action. So you can see coming an engineer pulling out the switchboard. That is to reset the test. So he's putting this in again. The test stand will automatically read out which system it is, serial number. You will see that the LEDs will go up now. So the links are up and running. We are going to the test system now. We can see how it reads out everything, configure the test, and just start the test. And when we going back to the system, we will also see that now the LEDs will flicker in a second. Correct, here is flickering, so traffic is performed. Quick last view on this test stand. So what is the conclusion out of here? So in general, why is switch testing so important? I think in the past, if we talk about a CAN bus, the network is just a wire, right? And most of the intelligence was in the antivirus and the interface. Today, with Ethernet switching and Ethernet networking, we have a lot of intelligence also in the network. So we're talking about interoperability between switches. A network is only performing like the, let's say, slowest device in this network in specific architectures. So it's very important to test the basics, right, in an Ethernet network. Every Ethernet switch will be influencing the whole communication within a network, and very important, you have to see the Ethernet communication as a full additional layer of application, where you can do misconfiguration, or when you have a problem on this communication layer, you will also have problems within the applications. And without validating these Ethernet communication in the beginning and revalidating this all the time in the engineering process, we'll probably have a lot of problems to troubleshoot problems in the higher layers, right? If you have an engine control unit which is not receiving specific messages or informations, you don't know if this happens in the application or probably in the network if you have not tested the network probably. So this brings us to our tagline: test, improve, repeat. Means have to test all components, all switch components, or your own switch products in the whole engineering chain. And during the engineering chain or the engineering, you troubleshoot and resolve problems instantly if you know the problems and if you have tested them. Then you can go into the repeat revalidation to prove the final functionality of your hardware and software. So last slide will show a little bit our solutions, what we do have for automotive Ethernet switch testing. In general, we have an automotive Ethernet test module. We have 6 dual speed, 101,000 base T1 ports. We have additional 2 ports of 10 base T1S, the new 10 megabit standard. Again, a bus system will probably replace CAN or LIN in the lower speed side. This test module can put into different chassis solutions. So we do have one test module system, which is our Valkyrie Compact. So we can have up to 6 ports plus 2 ports. We have the Valkyrie Bay with up to 12 test modules. So that means 72 100,000 base T1 ports and additional 24 ports 10 base T1S, and similar hardware is also used in our Vantage Bay. Same amount of test modules, 12 in some, where in Vantage we have just a little bit different kind of software. Valkyrie comes always with our CINA value pack, means all software is included and no thinking about options. You have 3 years of free warranty, 3 years software updates, and also very important, you get product lifetime tech support and training. Yeah? So you don't have to buy this additional. And the only software you probably have to buy it separately is our Vantage execution, because that is designed on customer base. So each customer has a different test execution within Vantage because it's fully automated. Again, thank you again, and have a great day.
Thank you, Mr. Thomas, for sharing with us the technology on automotive Ethernet switch testing. We request all the delegates to drop your questions in the chat box now, so that Mr. Thomas will solve your queries. For further updates and to know more on the technology and usage of tool, you can write to us at support@menlopark.com or marketing@menlopark.com. Thank you.